Okay, so today we'll be teaching about diodes or specifically PN junction diode. So what is diode? A diode is a semiconductor device that allows current to flow in only one direction, and it has two terminals, anode and cathode. So let's see how a diode looks like. The symbol of diode looks like this. So this terminal is the anode and this terminal is the cathode, denoted by K. So suppose you have an electrical circuit. Let us take any value of resistor, say suppose 1 ohm, and it's 10 volt. So what will be the current? The current would be obviously 10 ampere. Okay, now the circuit is working completely fine. Now let's insert a diode in the circuit and check what will happen. So this is the circuit, and suppose I inserted a diode here, diode in this configuration. So you will see that after inserting the diode in this configuration, the current is still the same. There is no changes in the circuit. Fine. Now suppose you want to connect the diode in a reverse fashion like this. So when you connect the diode like this, you can see that the current becomes 0. That is, the current will the diode won't allow the current to pass when you connect the diode in this configuration. It is because obviously by the definition, a diode is a semiconductor device that allows current to flow in only one direction. That means if the current is entering the anode terminals, this is the anode terminal, if the current is entering the anode terminal, then the diode will allow the current to pass. But however, if the current tries to enter through the cathode terminal, this is the cathode side, if the here the circuit, the current will try to flow in this direction, and you can see that if the current tries to enter the cathode terminal, then the diode will block the current. Okay, so basically the diode will allow the current to flow in only one direction, that is from anode to cathode, but cathode to anode current flow is not possible. So this was just a general introduction to the diode. Now let's dive into the characteristics of an ideal diode. So we will start with ideal diode. Okay, whether the diode will allow the current to flow or not, it depends upon the polarity of the voltage that is applied across the diode. So what is meant by the polarity of voltage? So this is the diode, this side is the anode, this side is the cathode. See, if the voltage at the point A, that is the anode voltage, it's greater than the cathode voltage, then only diode will allow the current to pass. And this condition, if the anode voltage is greater than the cathode voltage, this condition is called forward bias. Okay, only if this condition is satisfied, then only the diode will allow the current to pass. So obviously then if VA is less than or equal to VK, that is, if the cathode voltage is greater than the anode voltage, then the diode will block the current. And this condition is called reverse bias. Okay. So voltage A greater than voltage K, it means that the voltage A minus Vk greater than 0. That means the voltage, the voltage that is applied across the diode must be greater than 0 if we want the current to flow. So let's flow. Now let's denote the voltage across the diode as Vd, that is Vd. Obviously you can also write VAK. Basically VAK, Vd all means the same. Okay, Vd is the voltage across diode, which also means the voltage AK, and VA, this voltage must be greater than this point. Okay. Now suppose I have applied okay, I already told that okay. Now consider this circuit. Now as per the discussion, that is the voltage at the anode potential should be greater than the cathode potential. So with respect to this, I want to check whether the diode will conduct or not if the 10 volt voltage is applied. Okay. Now to check whether the diode will conduct or not, to check whether the diode okay, to check whether the diode will conduct or not, you consider that the diode is not working, that is the to check whether the diode will conduct or not, you consider that the diode is not working and it is in an open circuit condition. Okay, consider the diode is not working, diode is not conducting, and then check the okay. Now to check whether the diode will conduct or not, you consider that the diode is not conducting and then check the voltage across the points A and K, that is the anode and cathode. So what I mean is that you consider the diode is not working, it is an open circuit condition. So this is the anode, this is the cathode, this is the anode, this is the cathode, and now check the polarity of the voltage at the magnitude of the voltage at A and K, and see whether the voltage at this terminal, that is the anode terminal, is greater than the voltage at cathode terminal or not. So you need to check whether VA is greater than K or not. Okay, so how do we check voltage? To check voltage, we need a reference node in a circuit. So any circuit, if you want to check the voltage at any node, you need a reference point. So why you need a reference point? Suppose I draw any circuit here. So here I have a node A, I have another node B, here is also another node C. Now suppose I want to find the voltage at node A, voltage at node B, voltage at node C. So how do you calculate or measure voltage? We can measure voltage with the help of voltmeter or multimeter. Suppose I use a voltmeter to measure the voltage at any node. So suppose this is the voltmeter. Suppose this is the voltmeter. So in voltmeter we have two probes, and these two probes you need to connect to measure voltage. Now suppose I want to find the voltage across in node A, means I want to find VA, that is the voltage at node A. Okay, to find the voltage at node A, you can take one probe and connect it here. Okay, I connect it here, but just connecting one probe, there will be no reflection here. Obviously this second probe you need to connect somewhere. So to find the voltage at node A, where do you connect the second probe? So to measure the voltage at A, and as you need two probes, the voltmeter probes, to be connected in the circuit, so there is a solution. What is the solution? What you can do is that you can take this probe and connect it at any point in the circuit. Okay, at any of the nodes, if in any nodes you can connect the another probe. So this is obviously this C node only, this one. Then after connecting like this, you will get some deflection. Okay, so this is like this you can measure the voltage at point at node A. Now similarly, if you want to calculate the voltage at node B, what you can do is that you can the second probe, that is the second probe, you keep it connected like that, wherever that is the same point, you keep it connected and change the terminal, keep it connected and change this terminal and connect it here. You can measure the point B. Similarly, if you want to connect the voltage at point C, you can take it and connect it here. So this C and this is basically the same points, and when you connect it like this, here you will get a zero voltage. So the node where you have connected the second probe, that node we call it as a reference node. So with the help of that node, we can calculate the voltage at each and every node in the circuit. Okay, and which node should be selected as a reference node? So it can be any node in the circuit. The reference node can be at A, reference node can be selected as B, or the reference node can be selected as C. Okay, so the voltage, whenever we want to find the voltage at node A, we are basically finding VAK. Okay, whenever we are finding the voltage B, we are basically finding this will be A, this is VAC. Here also, if you whenever connecting the whenever finding the voltage at node B, we are basically finding VBC. Okay, and then what will be the voltage at the reference node? Here C is the reference node. What will be the voltage at C? obviously the voltage at C with respect to the reference node, that is C again, obviously it will be 0, means both the probes are connected at the same point. So the voltage at the reference node is 0. Okay, fine. Now let's come back to the circuit. Now first let's check what is VA. Here let's assume that this is the reference node. Reference node, we can, let's denote it as 0, okay, or O. This O represents the reference node. This is the reference node. So now what is VA? VA is basically VAO, and this is VAO, and this is basically 10 volt. Okay, the voltage across the node A and the reference node is 10 volt, as we can see from the circuit. Now what will be the voltage at point K? That is the, what is the cathode voltage? Cathode voltage is basically K, again VKO. Now we have considered that the diode is not conducting, it is an open circuit. That means there is no current flowing in the circuit now, and if there is no current flowing, then that Vk, that is the cathode voltage, and this reference voltage, reference node voltage are basically the same, because there is no current flowing. So Vk is equal to V0, Vo, and it will be 0 volt, because both this point and this point are at the same potential, so the voltage is 0. So obviously you can see that Va is greater than Vk, so diode will conduct, and we can say this is the condition of forward bias. The diode is in forward bias condition, and the diode will conduct, it will allow the current to flow. Fine. Now suppose I consider the voltage like this, and now I want to check whether the diode will allow the current to flow or not. How to check? Again, first, this is with the anode, this is with the cathode. First let's check by considering the diode not working. It is an open circuit condition, the open circuit across the diode, and then we will check the polarities of the voltage, or the voltage at point A. There is a anode voltage and the cathode voltage. If the anode voltage is higher than the cathode voltage, then the diode will conduct. So let's consider that the diode is not working. Okay. Again, let's consider this is the reference node. Reference node is denoted by O. So what will be the voltage? The voltage at A basically means VAO, and it will be, what will be VAO? Sorry. What will be VAO? VAO is minus 10 volt. Okay, so VAO is now minus 10 volt. So what will be VK? VK basically means VKO. What will be VKO? See, the current, there no current is flowing, so obviously this point and this points are the same potential, and it will be 0 volt. So minus 10 volt is greater than or less than 0 volt. Is less. So minus 10 volt is higher or lower than 0 volt. Obviously this is at a lower potential, and this is at a higher potential. So here Vk is higher than Vk. So this is a reverse bias condition. This is a reverse bias condition, and diode will not allow current to pass. Okay. So in summary, what we can tell, we can tell that suppose we have a diode, and if the current tries to enter through the anode terminal, this is the anode terminal, and if the current tries to enter through anode terminal, then the diode will allow the current to pass, and if the current tries to enter through the cathode terminal, if the current tries to enter through the cathode terminal, then the current will be blocked by the diode. Okay, so this is summary we can deduct from the whatever the explanation I gave now. Now suppose I want to draw the VI characteristics of a diode. Okay. Now suppose this is the voltage across the diode, that is VAK, and this is the current trying to flow through the diode. Okay, okay, then now how the VI characteristics will look like, we have discussed that if VD or VAK is positive, then the diode will allow the current to pass. Okay, there will be current if the VD is positive. So we have already studied that if the voltage at the anode terminal is greater than the cathode terminal, this voltage at this point is greater than this point, then the diode will conduct. Okay, so when VD is greater than 0, current can take any value. Why the current can take any value? It basically means the value of the current will be decided by the circuit. Suppose I have a circuit, this is 10 volt, this is because 10 ohms. So what will be the current through the diode? Here ID will be 1 ampere. Now suppose if I change the resistance as 5 ohms, what will be ID? ID will be 2 ampere. So basically, depending upon the circuit conditions, the ID value can take any value if the anode voltage is greater than cathode voltage. So how can we draw the VI characteristic? We can draw it like this. Now what happens when the VD is negative? VD negative means cathode voltage is greater than anode voltage. Obviously it don't allow the current to flow, that is ID will be 0 in that case. So here we can draw it like this. Okay, so this red line is the VI characteristics of an ideal diode. Okay, but this characteristics is not yet complete. Okay, so why not complete? See, suppose this is a diode and you applied a voltage like this. Obviously, in this circuit, the cathode voltage is greater than anode voltage, the diode would conduct. The diode would allow the current to pass, and in this circuit, current will be 0. Okay. Okay, fine. Suppose the voltage is now 100 volts, then also same condition. The diode won't allow current to flow. Suppose you now applied 1000 volt. So a high reverse voltage is applied across the diode. So when in these conditions, when the reverse voltage across the diode, there is a reverse bias voltage is very high. So the diode can withstand no problem up to a certain range of reverse biased voltage. The diode can withstand. Here the diode can withstand. The diode can withstand means it can retain its properties. That is not to allow the current to pass when it is in a reverse bias condition. Suppose the reverse bias voltage is 10 volt minus 10 volt. Okay, the current is not allowing the current. The diode is not allowing the current to pass. 50 volts minus 50 volts, same. Okay, the diode is not allowing the current flow. But suppose you applied a very high reverse voltage, then what can happen is that the diode can break down. Okay, and when the diode breaks down, it will lose its properties. It will lose the properties of a diode, that is blocking the current in negative direction, and the diode will start conducting. Suppose here I have applied a 2000 volt voltage across this diode. Vk is greater than Va here. So in this condition, the diode will break down, and we allow the current to pass. So here what will be the current? The current will be 2000 divided by R. Okay. So up to a certain limit, suppose this is the limit. After this limit, the characteristic will look like this. After a certain limit, look like this. And this point is the breakdown voltage. So means if you apply a reverse bias voltage whose magnitude is higher than the breakdown voltage, then the diode will lose its properties and it will start conducting. Okay, so this is the typical property of the diode, that is the VI characteristics of a diode. Basically this diode will look like this. This is the property of the diode. Okay, sorry, not the property, this is the characteristic. Okay, so this is the VI characteristics of a diode. This is the VI characteristics of a diode. Okay, so you can see one more thing. When the diode breaks down, okay, when the diode breaks down, that is the reverse bias voltage is higher than the breakdown voltage, then as I told, the current, it allows the current to pass. Okay, but one thing you should know, that when the diode breaks down, obviously it will allow the current to pass, but it will also, in this diode, across this diode, whatever is the breakdown voltage, that amount of, suppose this is the breakdown voltage, that amount of voltage will appear across the diode. Okay, what I want to tell is that, so after diode breaks down, okay, just one more thing, that whenever we use the term breakdown, it does not mean that a diode gets destroyed or something like that. Okay, breaks down means the same diode loses its property. So whenever the diode breaks down, then obviously it will allow the current to pass, and across the diode this voltage will appear across the diode. Okay, this is VBD. So after this is VBD, and this current will flow decided by the R. Okay, so the current can be anything depending on the value of the resistance, but the voltage across the diode will be constant at VBD, that is the breakdown voltage. Okay, so basically what will be the value of the current, you can apply KVL and you can find out. Fine. So if you apply KVL, it will be 2000 is equal to IR plus VBD. So what will be the I? 2000 minus VBD divided by R. Fine. So here I have not considered this breakdown voltage, but breakdown voltage, there will be a constant voltage across the diode when the diode breaks down. Okay, that is equal to the VBD. Now you might have question in your mind that what is the typical value of this breakdown voltage. So see, the diode is diode semiconductor device. Basically, two types of materials are used. There is a silicon or germanium. So for silicon diodes, if this diode is made of silicon diodes, this breakdown voltage typically ranges from like 50 to 1000 volt depending on type. So the breakdown voltage may be 50 volt if it is a heavily doped diode, and it may be as high as 1000 volts if it is a lightly doped diode. Okay, and for another material that is widely used is the germanium. So for germanium diodes, the breakdown voltage typically ranges from like 10 to 50 volt. It is very less in case of germanium diode. Okay, so whenever you use diode for any application, make sure that the reverse bias voltage do not cross this breakdown voltage of the diode, otherwise the diode will lose its property and it will start conducting. And see, whenever we talk about this condition, VAK must be greater than 0 in order for the diode to conduct. We basically see, this is the condition, and we check this condition by open circuiting the diode. Okay, we need to open circuit the diode, consider that the diode is not working, and then check the condition whether VA is greater than VAK. Okay, only during this initial condition check we consider this condition VAK, means we check this condition whether VAK is greater than 0 or not. Fine. If when we open circuit the diode, and if VAK is greater than 0, that means the diode will conduct, and when the diode starts conducting, then what will be the VAK? So VAK will be equal to 0 when diode is conducting. Okay, just remember this thing. And this condition, we check this condition by open circuiting the diode. Fine.